Oh, thank you. Thank you very much. As I said, I didn't get much sleep because, of course, I had to change the demo in the last moment to get stuff to work. So that's always fun. And so I'm going to talk about AirPlay in Node. And of course, I would like this to also work in the browser, so maybe it should just say JavaScript. But this is work in progress, and I haven't figured out how to do multicast NS in the browser yet, but we'll see. We'll see what happens. So my name is Thomas Watson. You can talk to me on Twitter and on GitHub there. And first, a history lesson. So AirPlay. There was a first generation of AirPlay. It was in 2004, and it wasn't actually called AirPlay back then. It was called AirTunes. And actually, AirTunes is just a fancy marketing name for a protocol called RAUP that Apple developed, which is Remote Audio Output Protocol. I'm feeling so sorry for the translators because I'm going to be using a lot of acronyms and protocol names and stuff, but hopefully it's gonna work out okay. So RAUP is or AirTunes is a simple protocol for you have your computer. This was before the iPhone, so there was you had your computer with iTunes running on it. You have your local area network, and you have a RAUP server, which is usually like an Airport Express, and you connect a physical speaker to that with an audio cable. And then you could stream music from your computer, from iTunes, over to your speaker. Then came a second generation. This was in 2010, and it was called AirPlay. Because a lot of stuff had happened between 2004 and 2010. We've gotten the iPhone. We got an Apple TV. So AirPlay is basically an umbrella name for both AirTunes 2 and the protocol called AirPlay, which is under the umbrella name AirPlay, so it's kind of confusing. But AirTunes 2, which is a new version of the AirTunes protocol, or the RAUP protocol, is basically still RAUP. It's just a little bit extended. And it works similarly. Now you can also connect your iPhone to your local area network, and you have an AirPlay server, and you can stream also stuff to a TV, as well as a speaker. So just to recap, RAUP, that's for audio. AirPlay, that's for photos, videos, and screen mirroring. So how does this work? How does these things figure out how to talk to each other? There is a service discovery protocol, which is using Apple's Bonjour protocol. But as some of you might know, Bonjour is basically just Apple's branding of something called JSConf. And JSConf is basically just running on top of multicast NS. So if we can do multicast NS, which we can in Node.js, then we can get started. Just a quick, so I'm going to show you here how this will work when you're using a RAUP, when you want to play music. That's the stuff I was trying to get to work last night. So the phone will query, say, is there any AirPlay servers? An AirPlay server will say, hey, I'm here, and I support these things, and you can do screen mirroring, or you cannot, or whatever. And then the phone will be like, cool, so if it's just concerned about doing audio, it will send an RTSP options request, which is basically a way for it to ask the server what kind of RTSP it supports. And RTSP is basically the protocol that RAUP uses to communicate. It resembles HTTP a lot. It's actually exactly like HTTP, except that they changed the first line, and then they called it RTSP. It is a proper RFC, so you can read about it in a 100-page long document, if you feel like that. The problem is that Apple added this thing to the right. To the right, yes. They added encryption. because, oh, no, we can't use this public protocol and not like know who we're talking to. And this is for a way for the phone to know, okay, am I actually talking to an Apple device here? Let's see. And this happened in 2011. Haha. Somebody got the private key of an Apple TV. So that's nice. That's nice. So now we can figure out what's going on. So it's sending a challenge that is encrypted using the public key, and what we have to do is we have to decrypt it. Then we have to add and pass it as a 32-bit unsigned integer. Then we have to add the IP of the server and the MAC address of the server, and encrypt that with the private key. Send it back to the phone, and the phone is going to be like, cool. You're like a proper Apple device. I know, like, I trust you. Then it will send an announce request, basically saying, I'm about to play something to you, and this is kind of like the codec, and I'm using these bit rates and stuff like that. And the server will be like, cool. And it will then be like, OK, I'm almost, I forgot what it was sending here, but it was sending something extra information, whatever. And then it's going to be like, OK, record, because it's kind of like this was something that was built, like the RTSP protocol is from the 90s, so it's thinking in terms of record and pause and rewind. So it's going to send a record request, and the server is going to be cool. And this is all over TCP. And then everything is set up. Oh, yeah. The setup thing was to set up the ports, because now we're going to switch to UDP, because it's going to be like we're going to just output a lot of high-quality data. It's going to be really fast. So it's going to set up 3 different ports that it's going to listen to. And that's what the setup request is for. And on the first port, it will send raw audio packets using UDP. On the second port, it will, out of band of the audio, it will send control packets to kind of like just say, hey, we need to do this or this. And the server can also send control packets back to say, oh, I didn't get like that piece of audio. Can you please resend it? And it will also send like a heartbeat every 3 seconds saying, hey, this is my time, and so you can sync multiple speakers in the room and all have them play in sync. And then you should have audio, right? Not really. Because of this, again. So, of course, they encrypted the audio, and they encrypted, it's really, I can't say that word here, stupid. And trust me, I spent a lot of time figuring out exactly what should be, how to decrypt this audio, because it's not encrypted normally. But it's still using the same key, but you have to decrypt it in 16-byte segments and not the last and only, and whoa. And then you have audio. Not quite, because well, you have audio, but it's in ALAC. Usually, if you have a modern phone or a new version of iTunes, it will send it in ALAC, which is Apple Lossless. And Apple Lossless, they open sourced that, I think in 2011, so that's cool. But it's still like usually your player is used to having it in a container format, so like MPEG-4 or something. And this is without the container format, which is why when they sent the announce request previously, it would tell us like, hey, this is like the bit rate, and this is all this stuff, and there's like a magic cookie you need to set, and it's really weird. So you can't just play this normally. You have to figure out a way to interpret this ALAC data. That was a lot of theory. But basically, RAUP uses the RAUP client and server uses 4 different ports. Some of it is for UDP, some of it is for HTTP, RTSP. And they kind of follow the standards. All of these are backed by RFCs. But Apple, of course, changed the last 2 a little bit, so they not really follow the RFC. And AirPlay, that's way easier. It's AirPlay over port 7000, which is using HTTP. Thank you. And then NTP for when you're doing screen sharing and you want to sync the sound and the video. And a lot of stuff about protocols. I thought I was going to, hey, I'm going to do this, and it's going to be easy. And we're like, whoa. Like, all of these have an RFC behind them, and I've become really good at reading RFCs, like really good at about reading RFCs. And these are just like a tip of the iceberg. All the audio codec stuff is not here, and the video codec stuff is not here. So luckily, I was not the first one to do this. Somebody else already reverse engineered the protocol back in 2011. Thank you. But Apple have changed it a lot since, so I need to buy this this router where I can do a man-in-the-middle attack, and on the Apple TV, and I use Wireshark to listen to the packages and stuff. It's really fun. So getting to the code, npm, npm is amazing. I love npm. All of this effort I've put into doing this have resulted in a lot of small modules that can be mixed and matched, because I don't just want to play or create like an AirPlay server that you npm install AirPlay, and then you just like have this magic box, everything works inside it. The reason why I originally started out doing this was because I wanted you guys to figure out fun stuff to do with this. So all this stuff has been broken down into small modules that you can use depending on what you actually are trying to achieve. This is just some of them. So now it's going to be interesting. I'm going to take the phone first here, and then I'm going to, let's see, how do we do it like this? Yeah. And then, hey, can you wave? Thank you. OK. So is this on the screen somewhere? There it is. Perfect. So let's go, whoa. Let's go to is this, oh, no. There we are. Can you see that? Cool. So what I'm going to do is I'm going to start AirCat, and I'm going to pipe it to foo.jpg. So this is going to be really interesting. Is it still on the right network? I hope it is. So now I have the picture here, and what I'm going to try to do is, I'm not on the right network or something is wrong. Let's just see. This is what I feared. I am on Watson. Yes, OK. Yeah. I feared this would happen. So, of course, this is a demo. What's supposed to happen is that I should be able to magically transfer this photo from my phone to my computer, which is something that you always you have your phone and you have a photo on it and you want to transfer it to the computer. And it's always like a pain in the backside. But apparently my phone is not picking up my computer. So we're gonna, I can't show that right now, unfortunately. What can be wrong? Am I on the, let's see, can we do a quick check here? Yeah. All this setup for nothing. At least I got a picture. Remember, drink more water. Yeah, OK. No fear, no fear. We can do stuff from the computer, too. So this is what I did last night. So the Wi-Fi is not working. We're gonna now work on. I'm gonna show you something that I did last night at 3 o'clock. So back to demo. So I made this Raub RTSP. I'm sorry, the name is not that good, but it was quick. So the idea is that we set up a server, and it will just enable debugging mode, so you can see that it's advertising using MDNS. I just realized the clock is not ticking down in the right-hand corner there. I have no idea how much time I have left. Apparently it's 27 minutes. Cool. So now it's running. So we're gonna go to iTunes, and I found some royalty-free music. And iTunes now, let's see, can we? How is it you do? Yeah, you zoom like this. So iTunes now have the name of this speaker that I just set up. And, okay, I'm gonna play it. And nothing happens right now, because, whoa. Oh yeah, I'm zoomed in, that was why. Thank you. Thank you. So it's sending a lot of control mechanisms back and forth, and right now I haven't redirected the output anywhere, so we can't hear the audio. This is on purpose, so I'm gonna stop this. And then I'm gonna redirect it to standard out, and I'm gonna use another program called SOX. SOX. Which is it's like the only program I've found that can actually play back this raw ALAC format. So it started, it's waiting for data. And and I can press pause, and it pauses. So this is on the fly, sending data from iTunes to a server on the network. It happens to be on my own computer, doesn't matter. Streaming out raw ALAC to standard out. SOX is then reading it from standard in and playing it back using core audio. So it's like, okay, job done. It was now 1 o'clock at night, and I was like, wonder what else you could do. And then I thought back to NodeConf a couple of weeks back. Me and Matthias Boos, Macintosh, on GitHub, we were like talking about how can you do like live streaming of torrents. And I'm not an expert. He is the live streaming torrent expert. Those of you who know him probably know that. And he's in the States right now. So I looked him up on RSC, and I was like, hey, we should really make this thing work with torrents, because then what we can do is we can put like an internet bubble in between the playing devices and the outputting devices. And then we can just stream this all over the internet. So we did that from 1 to 3. So let's see. So what I'm gonna do now is I'm gonna just open up another console here. But this, you have to believe me, this could work across the internet. Okay. So, and he made this wonderful thing called Peer Vision, and there is a CLI for it called Peer Visionary, which basically allows you to live stream torrents, which is kind of tricky if you think about it, because torrents are kind of like, you cannot change the content of a torrent, then like that doesn't work anymore. You have to produce a new torrent. But this works using some clever stuff that he can tell you about. What is it called? Something with curves and encryption. So, are we gonna just remove the debug flag here? No, let's keep it. It's fun. Then we can see a lot of stuff. Oh, and we tried to use gzip to compress the data. We're gonna remove that. It's not necessary now. It was a hotel internet. It was really slow. So, Peer Visionary will give me. This is basically my. If you're familiar with Magnet Link, in torrents. This is my magnet link. This is now a private key that I can use. And now it says DHT is ready. And let's play that. Now we attach a peer to the swarm, like this. And then we go in, play the music. Then hopefully, it's just going to buffer a little bit, and it's going to use the internet. What are you saying? Oh, yeah. Don't reuse the protocol. What? Okay. And like this. Whoa. Okay. And the cool thing about this is now that thank you, sound guy. Now that my peer is actively streaming this and receiving it, what I can do is I can join like a new peer to the network. And they will all, it sounds terrible, but they will all now both play the same audio, and they will all help each other stream the packets, so that the more people who join, the less load it is on the server. Let's stop this. How much time do I have left? 2 minutes? OK. It's really terrible that this thing didn't work, but, well, what are you going to do? You can do some torrent stuff instead, right? Live streaming torrents. Awesome. So, thank you.